Okay, this is your Unit 5, Lesson 3, Day 4 homework. This is coming from question number 8 on page 382 in the Core Plus Mathematics Series 2, Course 3 text. So question number 8 is asking us to write each of these sums and differences of rational expressions in equivalent form as a single algebraic fraction, then to simplify the result as much as possible. So we're going to look for common denominators when they exist and use the helpfulness here. So here's what we start with. We have 4x plus 13 over x minus 3. We're going to add that to x plus 2 over x minus 3. And right away I see that x minus 3 is a common denominator. So we'll leave x minus 3 as a common denominator there. And then combine the numerators. 4x and x combine to be 5x. 13 and a positive 2 become 15. Now, we're also told to simplify the result as much as possible. Well, you might notice that 5x and plus 15 can be factored into, I pull out a 5, it turns into 5 times x plus 3 all over x minus 3. And I see that and kind of go, ooh, I'd like to cross this off, but I can't do that because that would change the sign, and I don't have that ability. So this is actually the simplified version, either as 5x plus 15 over x minus 3 or as 5 times x plus 3 over x minus 3. So that is part A. Let's go to part B. Part B reads 3x plus 7 over x minus 2 minus x plus 5 over x minus 2. Now a little caution here, that minus sign is going to apply to both those terms in the numerator. However, the denominators are the same. They're common denominators, so we just write x minus 2 on the bottom. And what I'm going to do is do 3x minus x gives me 2x, but then 7 minus 5 gives me a value of positive 2. All right? And then when I look at this expression, I could factor out a 2. I could factor the 2 out and it becomes x plus 1 on the top. Then I have x minus 2 on the bottom. Nothing else cancels out. So either one of these is equivalent to each other and acceptable for the simplest form. In part C, I have x plus 2 plus x plus 6 over x minus 4. So what we might notice right away is that this x plus 2 over here isn't a fraction. So what we're going to do is turn that into a fraction. We'll make it x plus 2 over 1 plus x plus 6 over x minus 4. Now to have a common denominator, I need the left addend to become, to have a common denominator of x minus 4. So I need to multiply that by x minus 4 over x minus 4. And I have not have to do anything to the addend on the right, because the addend on the right would multiply by 1, and multiplying by 1 doesn't change things. Whoops, I put a negative there by accident, my pen mark. So now I have this expression. I have to go ahead and simplify this as much as I can. What I'm going to do is multiply together this x times the x to get x squared. I multiply x times the 4 to get negative 4x. 2 times the x to get positive 2x. I'll walk away with a negative 2x combined. And then 2 times the negative 4 is a negative 8. And we're adding that to x plus 6 over x minus 4. Combine the numerators. X squared, negative 2x and a positive x is a negative 1x. Negative 8 and a positive 6 is a negative 2 over x minus 4 on the bottom. And that is the simplified version. If I could factor this and cancel factor out, I'd go further. Can't do that here. So this is my simplified version. D. D looks the most daunting, but it does have a common denominator. So we should be able to deal with that common denominator in a moment. We're subtracting, so we want to be careful that we actually subtract the opposite or add the opposite to everything on the top over here. So in doing this, the subtraction would end up with x squared minus 25. And I'm going to be very careful here. 3x squared minus 3x squared goes to 0x squared. 5x minus 4x is 1x, or just x. And then 1 minus a negative 4 becomes 1 plus 4, which is 5. So I have x plus 5 over x squared minus 25. And here I actually get to see one more step. X squared minus 25 is the difference of perfect squares. So that means I can factor that into x minus 5 times x plus 5. And then I can see the x plus 5 actually goes away too. And I get 1 over x minus 5. And that is the final result for 8D. That's the end of 8.